Hello everyone, this is Haddad here again. In this lecture, I'm going to explain to you about the stub areas. This topic has a lot of confusion for many students. So what is stub area in OSPF and why do we need to use them? And what are the different types of stub areas? So in this lecture, I'm going to make it as simple as possible. I'm going to pass through all the stub areas in OSPF and I will explain each one by itself. And after that, when I finish this lecture, I'm going to do some labs about the different types of stub areas we have on OSPF. Okay, as you can see here, I have this diagram. We have the backbone area here, which is area 0, connected to area 1. And then we have also here area 2. And then in area 1, we have the RIP network. So now let me explain what is the idea of the stub area. So some areas in OSPF, we really need to make it simple. Like for example, the area here, area 2. Okay, the routers inside area 2 that needs to communicate with other routers in the OSPF, for example, on area 0 or area 1. The only possible way for them to go is through the ABR, correct? So ABR is like their gateway. So for this reason, it's always recommended that we can make it as a stub area, because in this case, when we configure stub area, then we will see, when I explain in a moment, that the LSA type 3 and the LSA type 5, depending on what stub area we are configuring, but those two LSAs, they will be blocked in our areas, and then they will be replaced by a default route coming from the ABR inside the area. That means, in this case, we have the link state database becomes smaller and the routing table becomes also shorter, and that's all happens inside the routers in this area, and this helps to have less processing on our routers in this area, and also the memory usage will be also less. So that's really the idea behind the stub areas. So now we know what is the idea here about the stub areas. Let me go one by one on each of the stub areas we have, and then explain when we configure it what will happen in our area. So the first type of stub areas we have the stub. Okay, stub area. So say we go here to area 2, okay, and we configure this area as a stub. When we want to configure an area to be a stub, we need to configure the stub on all the routers inside this area, okay? When we make an area a stub area, in this case, the LSA type 5 will not anymore get inside this area. So LSA type 5. Remember, what is LSA type 5? LSA type 5 are the external routes, okay? So if I put here on this tab, so the LSA type 5 will be not allowed to come anymore to this area. For example, in this case, we have here RIP, okay? And we have, this is an ASPR, okay? Because it is redistributing RIP inside OSPF. And we have seen already about how to make the redistribution. Then the LSA type 5 means the routes, the external routes coming from RIP to OSPF will go to all these areas. But when it comes here, when it comes to this area, okay, the ABR here, the router number 3, will not allow them. So that means that the external routes, what we have seen before also when we were doing the configuration, they will not be shown anymore to the routers which are in this stub area. Okay, so this is really the idea of the stub area. Okay, so it will block all external routes and will not allow them to come inside this area. For this reason, you cannot configure a stub area, for example, in area 1. Okay, you cannot make it a stub area. Why? Because you have here router 7 is an ASPR connected to RIP. So you should not configure a stub area on an area which has an ASPR. Okay, so now we know what is the stub area. Let's look what is the total stub area. Total stub area is the same as the stub area. So it blocks the LSA type 5, which are the external routes, but in addition, it blocks also the LSA type 3, and that's what we've seen it before. It's the inter-area routes. That means the routes which are coming from other areas from OSPF. For example, this route over here, this route, and this route, all those, normally they come to here, and the router here, you can see them in his routing table. Okay, so these are the routes, or the inter-area routes, means routes coming from other areas in OSPF, and router 6 can see them. So this type number 3 also will be blocked. That means that router 6 at the end, if we make it a totally stub area, he will not see any external route in his routing table, and he will not also see any inter-area routes. He will only have a default gateway. That means if you want to reach any of those routes, he will send it to the ABR without really knowing what is happening or what is the network outside. And that's really can help, as I've said before, to reduce the CPU processing and the memory usage inside our router 6 or inside our totally stub area, which is in this case we have router 6. Okay, so this is what totally stub area. Again, stub, it only blocks LSA type 5. Totally stub area, it blocks the LSA type 5, which are the external route, and also the inter-area routes, the LSA type 3. Okay, NSSA or not so stubby area, that's the third type of stub areas. Okay, so what is NSSA? Actually, NSSA is the same as the stub. Like we said in the stub here, it will block the LSA number 5, and NSSA also, it blocks the type number 5. Okay, but why do we need NSSA? In case we have like here, like area 1, okay, and we really want to make this as a stub area, okay, but we said that if we want to make it a stub area, then it will block all LSA type number 5. And in this case, that means that the RIP will not be able to be redistributed inside this area. So instead of making it stub, what we can do, we can make it not so stubby area. So what will happen here, that when the RIP is being redistributed here inside this area, from, of course, this happens from router 7, the ASPR, inside this area. Then here he will send the external route as type 7 and not as type 5, because we said that type 5 on NSSA is blocked. So we send them LSA type 7, and that's especially for the case we have over here. And it's like a trick to be able to redistribute the external route inside the OSPF. And then these external routes, which has been redistributed as LSA type 7, when it reaches the ABR over here, because this is connected between area 0 and area 1, so it's an ABR. So when it reaches the ABR router 2, then the ABR over here, he will send them again inside, for example here inside area 0, he will send them again as type number 5. Okay, so NSSA is a stub area, but it allows the redistribution, and in this case the type 5 external routes will be type 7 inside the NSSA, and when it reaches to the ABR connected to the other area, then this ABR will make them again type 5 and send them inside the area. Okay, so this is NSSA. Okay, so normally you use it when you have an ASPR. Okay, NSSA is always used when you have in this area an ASPR connected. So as a very fast review, we said that the stub area, it will block all external route LSA type 5. Totally stub area will block also type 5 external route, but also it will block the inter areas route type 3. The not so stubby area will block type 5, but it will translate them or make them into type 7 to allow them to go to other areas. Now the totally not so stubby area now is the same as the totally stub area. That means it will block type 3 and type 5. Okay, but at the same time it will allow the external route to go as type 7. For example, if we make again this area a totally not so stubby area, then type 3 and 5 will be blocked. But in case again the ASPR is redistributing here RIP, then they will go as LSA 7 again to here to the ABR, and the ABR will make them as type 5. Okay, that means in this area he will not see the inter areas anymore. Okay, the route which are from the other OSPF areas. So with this explanation, I have already covered all the topics in the stub areas. So we talked about the stub, the totally stub areas, the NSSA and totally NSSA. The other points that I would like to mention here is when you want to make a stub area and totally stub area, you should to have at least one ABR. Okay, one ABR is needed to be able to do the stub area and the not so stub area. The backbone area over here cannot be any type of these stub areas. Okay, so the backbone area is not included inside what we call the stub areas. So it cannot be a stub area, it cannot be a totally stub, it cannot be an NSSA, and it cannot be also a totally not so stubby area. Okay, when you want to configure your stub areas in area, you should configure it in all the routers in that area. Okay, and in this case here, if you make, for example, on area 2 this router stub, and this one you didn't do it, the ABR, then in this case they will lose the neighborship also, because we've seen before when we were talking about the hello packet that stub, it's also a criteria that needs to be matched when you want to make neighborship together. Okay, so when you want to configure stub, you have to configure it on all the routers in that area that you want to make it to be a stub. And then at the end, when you want to configure the not so stubby area and totally not so stubby area, then in this case you should have an ASPR. Okay, otherwise why you need to make them not so stubby area or totally stubby area. Okay, so this is what I wanted to explain now. I hope that the stub areas now are more clear for you, and let's go now directly and start doing the labs about the stub areas.